In this video, we'll explore redox concepts, types, and their real-world impact, and also get to know what oxidation numbers are. What are redox reactions? Redox reactions involve electron transfer. They're vital for energy production, corrosion, cellular functions, and many other processes. Oxidation. Oxidation is a chemical process in which a substance loses electrons. This process often involves the addition of oxygen or the removal of hydrogen from a molecule. Oxidation typically occurs alongside a complementary process called reduction, where another substance gains the electrons lost by the oxidized substance. Together, these processes are referred to as redox reactions, short for reduction-oxidation. In terms of electron transfer, oxidation is defined as the loss of electrons by an atom, ion, or molecule. During oxidation, the oxidation number, a measure of the degree of oxidation of a substance, increases. In many cases, oxidation involves the chemical combination of a substance with oxygen, such as in combustion or rusting. Examples of oxidation reactions. In burning, a fuel reacts with oxygen to produce carbon dioxide, water, and energy. Rusting. Iron reacts with oxygen and water to form hydrated iron oxide. In cells, glucose is oxidized during cellular respiration to produce energy in the form of ATP. Oxidation numbers. Oxidation number, also known as the oxidation state, is a concept in chemistry that indicates the degree of oxidation or reduction of an atom in a chemical compound. It represents the hypothetical charge that an atom would have if all the bonds in the compound were purely ionic. It reflects the ability of an atom to acquire, donate, or share electrons. Oxidation numbers are useful for understanding redox reactions, electron transfer, and the overall charge distribution in a molecule. Understanding oxidation numbers is key to balancing redox reactions and predicting chemical behavior. How do you determine the oxidation number of an element? Determination of oxidation numbers of elements follow general rules. I will mention the most important ones here. 1. For a pure element, that is element in free or uncombined state, its oxidation number is always 0. We can mention examples like elemental oxygen, hydrogen, and sulfur. 2. Monatomic ions. The oxidation number of a monatomic ion equals its charge. For example, oxidation number of sodium ion is +1, and that of chlorine ion is -1. 3. Hydrogen. In most compounds, hydrogen has an oxidation number of +1. However, in metal hydrides such as sodium hydride, it has an oxidation state of -1. 4. Oxygen. Oxygen usually has an oxidation number of -2 in compounds, but there are exceptions. In peroxides such as hydrogen peroxide, it is -1, and in compounds with fluorine, for example in oxygen difluoride, it is +2. 5. Alkali metals, group 1 metals. They always have an oxidation number of +1 in compounds. 6. Alkaline earth metals or group 2 metals always have an oxidation number of +2 in compounds. Halogens, fluorine, chlorine, bromine, and iodine. Fluorine in compounds always has oxidation number of -1, and other halogens usually also have -1, but can show positive oxidation numbers ranging between +1 to +7 when combined with oxygen. The sum of oxidation numbers. In a neutral compound, the sum of oxidation numbers of all atoms equals to 0. And in a polyatomic ion, the sum of oxidation numbers of all atoms equals to the charge of the ion. To determine the oxidation numbers of atoms in chemical compounds, the following steps are required. 1. Identify the element whose oxidation number you want to determine. 2. Assign known oxidation numbers according to the rules discussed previously. 3. Write an equation in which the sum of all oxidation numbers of the atoms equals the charge of the compound or ion. 4. Solve the equation for the unknown oxidation number. Determination of oxidation numbers. What is the oxidation number of sulfur in sulfate ion? Step 1. Understand the compound and identify the element whose oxidation number you want to determine. In this case, it is sulfur. Step 2. Assign known oxidation numbers. Oxygen and sulfate ion has an oxidation number of -2, according to the rule for oxygen. Let the oxidation number of sulfur be x. And let's solve for x in the equation. X plus 4 times into bracket -2, bracket closed equals -2, x equals +6. This implies the oxidation number of sulfur in sulfate ion is +6. What is the oxidation number of Mn in potassium permanganate? Assigning known oxidation numbers, potassium equals +1, alkali metal, oxygen equals -2, according to the rule for oxygen. Let oxidation number of Mn be x. From the equation, 1 plus x plus 4 times into bracket, -2 equal to 0, x equal to +7. This implies the oxidation number of manganese in potassium permanganate is +7. How do you determine the oxidation numbers in copper sulfate? Step 1. One needs to understand the compound. Copper sulfate is made of sulfate ion, which has a charge of -2, and copper a single element bonded to the sulfate ion. These two species can be handled separately. Step 2. Assign known oxidation numbers. In sulfate ion, oxygen has an oxidation number of -2, and letting S be x, we can solve for x in the equation, x plus 4 times into bracket -2 bracket closed equals to -2, x then will become +6. This implies oxidation number of sulfur in sulfate ion, and for that matter in copper sulfate is +6. I have been explaining for some time now, so let's take a look at some questions you may encounter during the exams. Determine the oxidation state of manganese in each of the following compounds. 1. Manganese dioxide. 2. Manganese heptoxide. Let us start from question 1. Oxidation number for oxygen is -2. Let Mn be x. Solving for x in the equation, x plus 2 times into bracket, -2 bracket closed equals to 0. We'll give x equaling to +4, which implies the oxidation state of manganese in manganese dioxide is +4. Question 2. Manganese heptoxide. Oxidation number of oxygen is -2. Let Mn be x. Solving for x in the equation, 2x plus 7 times into bracket -2, bracket closed equals to 0. X results to +7, which implies the oxidation state of manganese in manganese heptoxide is +7. Here is another question. Determine the oxidation numbers of the elements involved in the following compounds. 1. Phosphoric acid. 2. Potassium nitrate. 3. Potassium aluminium fluoride. 4. Nitrite ion. Let's solve the questions together. 1. Phosphoric acid. Oxidation number of hydrogen is +1, according to the rule for hydrogen. And oxidation number of oxygen is -2, according to the rule for oxygen. Let's solve for phosphorus. Let P be x. 3 times 1 plus x plus 4 into bracket -2, bracket closed equals to 0. X equals to +5. Oxidation number of phosphorus is +5. 2. Potassium nitrate. Oxidation number of potassium is +1, according to the rule for alkali metals. Oxidation number of oxygen is -2, according to the rule for oxygen. Let's solve for nitrogen. Let N be x. 3 times 1 plus x plus 3 times into bracket -2, bracket closed, equals to 0, x equals to +5. Oxidation number of nitrogen is +5. Question number 3. Potassium aluminium fluoride. Oxidation number of potassium is +1. Oxidation number of fluorine is -1, according to the rule for fluorine. Let's solve for aluminium. Let aluminium be x. 3 times 1 plus x plus 6 times into bracket -1, bracket closed, equals to 0. X equals to +3. Oxidation number of aluminium is +3. Question 4. Nitrite ion. Oxidation number of oxygen is -2. Let's solve for nitrogen. Let N be x. X plus 2 times into bracket -2, bracket closed equals to -1. X equals to +3. Oxidation number of nitrogen is +3. Thanks for watching, and don't forget to like, comment, and share.